Good evening, class. Today we're going to talk about exploring surface area using nets of regular prisms. Today's learning target, I can describe and find the surface area of regular prisms using nets. This is a 7th grade standard, solve real-world and mathematical problems involving area, volume, and surface area of 2 and 3-dimensional objects composed of triangles, quadrilaterals, polygons, cubes, and right prisms. So, before we begin, I'd like to talk about some vocabulary words that you should be familiar with. In the 6th grade, you really only talk about two-dimensional shapes, but in the 7th grade, we begin to talk about three-dimensional shapes. So when we talk about three-dimensional shapes, I'm going to refer to them as solids. Solids are three-dimensional shapes that encloses a space. A polyhedron is a solid whose faces are all polygons. This figure, this solid, is a rectangular prism which all the faces are rectangles. Now, face is something you should be familiar with. In 6th grade, we talk about it a lot. A face is a flat surface of a polyhedron. Now, an edge. An edge is a line segment where two faces intersect. So right here on that blue line, that is an edge. And a vertex. A vertex is where three or more edges intersect. So this green dot, each one of these corners is a vertex. Some other vocabulary words in the 6th grade you should be familiar with. Area. Area is the inside space of a figure. Now, most 6th graders do know how to find areas of each of the following shapes: rectangle, triangle, and circles. But just to clarify, anybody that doesn't remember, does anybody know the area formula for a rectangle? That is right. Area equals length times width. What about a triangle? Does anybody know what area equals on a triangle? Area equals base times height divided by 2 when finding area for a triangle. And for a circle, we have pi times r squared. So what happens when we talk about 3D shapes? When we need to find surface area or area. Surface area is the total area of each face of the three-dimensional object. For example, I have a cube. This picture is a picture of a cube. It has 6 faces. And if I add up the area of each face, that gives me my surface area. What happens when we're talking about 3D shapes or 3D solids that does not have the same area? For example, a rectangular prism. Well, we could use nets, and a net is taking the solid and cutting it where it flattens out straight on a table. Flat, straight on a table. So next we're going to talk about our Desmos activity. This is exploring surface area of rectangular prisms using nets. So I'm going to click on that. Everybody has this activity, so you go ahead and follow along on your Chromebooks. All right, on slide number 1. Slide number 1, it wants us to find the dimensions of the red and blue rectangles. So if I'm looking at this net, this is a net of a rectangular prism, I need to count up the units. So on the blue, it's between 2 and 3, so that's 1 unit, and the size going up is 3. So the blue is 1 by 3, and my red rectangle, if I count it up, is 1 by 2. So 1 by 2. Does everybody see that? Are there any questions on this slide? All right, great. Now I'm going to skip ahead to slide number 4 because they all do the same thing. It wants you to move these points, these vertices, and basically if I move these vertices, my areas for each rectangle either gets larger or smaller. Now, if everybody will go to slide 5. Slide 5 is a challenge. It wants you to create a net where all the rectangles are 4x4 units in length. So 4x4 units. So I'm going to go ahead and do that. I'm going to stretch these vertices to make a 4x4. So my black rectangles are 4x4. My red are now 4x4. So I'm going to go ahead and D equals 3, and it gives me my 3D shape. So we have a cube, 4x4. Now let's talk about surface area of this cube. We have each face has an area of 16 units. 4 times 4, length times width, is 16. So I have 16 units and I have 6 sides. So I'm going to multiply 16 times 6, and that's going to give me a surface area of 96 units squared. So I know that was pretty quick, but we're going to go ahead and move on to slide number 6. And I'm going to let you guys do this one on your own, and then we'll talk about it after you're finished. So it wants you to make the black rectangles a 3x3 units, the red and blue rectangles 3x5. So I'm going to go ahead and do that. 3x5. So I'm going to move these. Red needs to be 3x5 as well. And I need my blue to be 3x5. And it wants me to put F equals 6. And I have a rectangular prism. So there's my 3D shape. Now let's talk about surface area of this rectangular prism. So I want to only talk about the blue rectangles. The blue rectangles are 3x5. So if I multiply 3 times 5, I get 15. 15 units. There are 2 of those. So 15 times 2 equals 30. So that's my blue rectangles, area of my blue rectangles. Now let's talk about the red rectangles. The red rectangles, each one is 3x5 as well. So I'm going to do the same thing. 3 times 5 equals 15 units. There are 2 red rectangles. So I also have 30 units squared for the red rectangles. Now let's talk about the black rectangles. So the black rectangles are 3x3. So if I multiply 3 times 3, I get 9. Well, 9 times 2, because there are 2 faces that are black rectangles, I get 18 units squared. So to get the surface area of this rectangular prism, I must now add my areas of the black, red, and blue rectangles. So I have 30 plus 30 plus 18, and that equals 78 units squared. And that's all it is to it for finding surface area of a rectangular prism. Now, if everybody will go to slide number 13, I'll let you guys find the total area or the surface area of this rectangular prism, and then we'll talk about our individual activity of finding surface area of triangular prisms, triangular base pyramids, square base pyramids, and cylinders. So I'll let everybody have a minute to find the surface area of this rectangle.